So let's take a look at these two curves and these two histograms and discuss some of the things that make them the same and some of the things that make them different. So by looking at the shape for starters, let's take a look at the shape. And if we just make a sort of curve that follows the top of the histogram, we notice that that one looks like a bell shape. And so does this one. So they're both bell-shaped graphs, so the shape is the same. And layman's terms say that this is a bell curve, but mathematically speaking, we call this a normal distribution. This is a new piece of vocabulary here. The other thing that's the same in both of them is the mean. And if you notice here, the mean is sitting right here, and there's no numbers on here, so we're assuming that the same scale, but then the mean is in the same place. So the mean is the same. Now, they're still quite different though. One is goes very high. The first one goes very high and is very narrow, and the second one is wider. So the graph A, or histogram A, is narrower. And what that means is that there are more data points at the mean and less at the two extremes. And graph B, on the other hand, has fewer points at the mean and more at the extremes. So the graph B is wider in shape. So what that means is that there is more variation in histogram B. The things are spread out. There, if you, for example, imagine that this is test scores, and let's say this is 67 average in both cases, then there are going to be more students that have a higher result than in this test here. There's going to be very few people that score very high. So there's more variation in histogram B. And that variation is going to have a special name. It's going to be called the standard deviation. So we'll chat more about that as the lesson proceeds. So here we go again with two histograms. This time they're two histograms that are plotted on the same graph, and they're just graphed in different colors. And pink they've chosen for the females, and blue for the males, and it's a graph about the heights of adults. But what I want you to see is that this pink graph has a bell shape, and the blue graph also has a bell shape. So it's not a perfect bell curve like the last example was, but it's pretty close. So they're both normal distributions. But in this case, the mean is quite different, and we know that just from practical observations, that women tend to be a bit shorter than men, and that's what these graphs represent. So the mean approximately, I would say, of females is about here, and of males is right there. So in this case, the thing that's is different is the mean is different. Now, because they're both normal distributions and they have the same height and the same width, we can also say that the variation in them is the same. So that means that in the standard deviation, which is what we're going to measure this variation by, is the same, but more on that to come. So let's take a look at these two before we answer the question. The first thing I want to take a look at is the mean. And notice that both of these have a mean of 2. They're also both symmetric. They're both the same on both sides of the mean, although they're completely different shape. This one is called the normal distribution, and that is because it has that classic bell shape. But both of them are symmetric. So the question is, which one has more variability? So in the first graph, most scores are 2, and there's only a couple that are have a score, a really high score or a really low score. So that means most of the scores are centered around the mean. Here, on the other hand, very few scored the mean, but lots scored very low or very high. So that means this graph here has the larger variability. So as you can see, the mean doesn't tell you everything about the data set. Variability is a really important description of what a data set looks like. So as I was hinting at in the previous slides, the variation has a name. It's called standard deviation. And the standard deviation has a mathematical symbol. It's got this funny little squiggly, and it's a Greek letter called sigma. And sigma has a formula, and the formula is going to be found on your formula sheet, and it looks pretty intense, but if you break it down to its parts, it's quite simple. It is, you take every data point, which we'll call x, and subtract the average, and then you square that number, and then you add them all up. So this symbol here means add it all up. That's sigma, that funny E shape means add it all up, and divide by the number of data points you have, and then you take the square root of it. So we're going to be practicing using that formula, but sigma tells you how much variation there is. So a graph that has a wide graph compared to one that's narrow, this one would have a large sigma, and this would have a small sigma. Now, sometimes you will see that formula in a little bit of a different way, and I just want to make sure that you understand that we're not going to make too much of a big difference about these two, but you might see it this way. And notice that this and this look different. Mu is the symbol for the mean of the population. So if you measured the entire population, what is the average? And sigma bar is the mean of a sample. So that means if you're only measuring 100 females for height, then it would be a sample versus all of the people, all of the females in the entire population. So there you'll notice a little bit of a difference there, but we'll be doing some practice questions about that.